so whenever, and let me go back, so whenever we talk about sequence and series, whenever we have a sequence given to us, okay, what that means is you're going to have a rule. Okay, your rule is usually just a sub n equal to n plus 1, like on number 9's case, or negative n to the third power. The n is just the number that you're plugging in. Okay, so like if I would set this up as far as like number 9 is concerned, if I'm doing my first 6, now I'm not telling you have to draw a table. I'm just kind of showing you how this all works. So like if we're using a sub n and n plus 1, what's going to happen is you're going to have like a sub 1, you're going to have a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6. Okay? A sub 3 is your third term. Okay? That number that you have, like the 1, the 2, the 3, the 4, the 5, the 6, that's the number that you're going to plug into your rule or your equation. Okay? You've been doing this for a long time now. Now we're just getting into like what does it look like. Okay? You've been plugging numbers into equations since you were in like a pre-algebra class or an algebra 1 class. Okay? But like for a sub 1, all we would do is just take 1 plus 1 and we would get a value of 2. We would take 2 plus 1 and we would get a value of 3. Okay? 3 plus 1 and we would get a value of 4. Then it would be 5, 6, and 7. So as far as the first 6 terms that we would have 2, 3, 4, 5, 6, and 7. Okay? Whenever we write it as a sequence, you would just basically put the number and you would just put a comma between the two. Same way if we did one like, let's say like number 19. Okay? Because we're not going to go through all these, but you're going to get the idea. I'll kind of separate it out this way. So like on 19, if I would write the first 6 terms of my sequence. So every time I would still have a sub 1, I would have a sub 2, a sub 3, 4, 5, and 6. Okay? Those sub numbers, the sub 1, the sub 2, the sub 3, again, those are the ones. So like if we're doing 19, that's going to get plugged in for the n value, or what you're accustomed to seeing is like x or y or q or z. It's just going to get plugged in. Okay? Hopefully what you start to see is that there is a pattern developing. Okay? So like if I have n plus 2 divided by 2 times n, like for the first term in my sequence, I'm going to have 1 plus 1 divided by 2 times 1. Excuse me, plus 2. My fault. So n plus 2, or 1 plus 2, so is 3. So what's the first term in my sequence? 3 over 2. Okay? So the first term in my sequence is just 3 over 2. Do the same thing for the second term, and I would take 2 plus 2 divided by 2 times 2. So what's the second term in my sequence? Just 1, right? Do the same thing for my third term. So 3 plus 2 over 2 times 3. So 5 over 6. The one thing I would not do is I would not write this as a decimal, but write it as a fraction. If it can simplify, simplify it like we did the 1. Okay? Obviously, we could have wrote 4 over 4. That's the same thing as 1. We would do it again. What's the next term going to be? Could you tell me what the next term is going to be without even plugging it into my rule or my equation? Or have an idea? If you can't, that's fine. 4 plus 2 over 2 times 4. So 6 over 8. What is 6 over 8? 3/4. Do the same thing with 5 plus 2 over 2 times 5 and get 7 over 10. Now, and I'm going to write this kind of below as far as what we did. We had 3 over 2. Like this is the simplified version. 4 over 4. Then we had 5 over 6. And then we had 6 over 8. And then we had 7 over 10. What's the next number going to be? 8 over 12? Yeah. Right? Okay, so if you want to do it, like if you see what it is without simplifying it first, that's fine, and then rewrite it. Like, how are you going to simplify 8 over 12? Like, what can you divide both of those by? How much? 4 over 6 or 2 over 3? Everything is going to have some sort of pattern. It's just a matter of you figuring out the pattern. Okay, if you can figure it out 2 or 3 numbers in, then you may not have to plug it in 6 different times. Does that make sense? Okay, so I would try to do that if at all possible. Okay, as you go. So like here it says writing rules. We're not gonna so much write the rules right now. We'll worry about writing the rules whenever we get into section 2 and section 3. So anytime that it says to write the rules, don't worry about writing the rules because I'm going to show you, because all you're going to do is spin your wheels for some of them. And so it's going to be a lot easier for me just to show you how to do it the next 4 days than it is to like get you to stress out and kind of freak out about not knowing how to do it. Okay, because I'm going to show you a lot easier way. What I do want you to do is be able to write like the next term in the sequence so you can kind of see what's happening. So like on 21, what's the next number coming up? Like if it goes 1, 3, 5, 7, 9. If on 24 it goes -5, +10, -15, +20, what's the next value? -25. Now, like so Madeline, like you asked this question, like since this one's not simplified, then I'm okay with you not writing the next one simplified. Does that make sense? So like if it had it as 1/3, 2/3, 1, then I would tell you write the next one as 2. But since they didn't, if they don't simplify it, then I'm okay with you just writing this as 6 over 3. Does that make sense? So kind of just see what you have and go from there. Same way like on 28 where they have, you know, it goes 120, 1 over 20, 2 over 30, 3 over 40. Like we obviously could simplify here and here. If they don't simplify, you don't have to. Okay, fair enough. So if they don't simplify like and have 5 over 60, you don't have to simplify 5 over 60 or reduce it. Right? What's the rule for 23? On 23? What about here? I agree that it looks like that the first three, but it doesn't hold true the rest of the way out. The thing with the rule is it's going to work all the time, every time. So this is why I don't want you to write rules because I want you to figure out. I would rather just show you how to do it without you trying to guess and check sort of thing. Any ideas about what the next number in the sequence is going to be? So originally we thought, hey, maybe we multiplied by 2 every time, but the problem is whenever we got to here, it didn't really work. Okay? That's okay. That's why we want to check to see what else can we do. There's really only 4 things that we can do to any number, right? We can either add, we can subtract, we can multiply or divide. So what are we doing to the next, like to go from 2 to negative 4? What did we have to add to 2 to get that? We added a negative 6, right? What did we do to go from a negative 4 to a positive 8? Added 12. What did we do to go from 8 to negative 10? What did we add? What did we do to go from a negative 10 to a positive 14? Add 24. What do you think we're going to add the next time? Is it going to be a positive or a negative that we're going to add? It's a negative. What are we're going to add what negative number? It goes 6, 12, 18, 24, 30. But it's going to be a negative 30. So what is 14 plus a negative 30? A negative 16. The biggest thing with any of these is try to look. It's mainly always look at either multiplying or adding. Okay? Because subtraction is the same thing as addition. It's just with a negative number. Same way with division. Division is the same thing as multiplication. It's just with a fraction. Okay? Whenever we talk about series notation, so the difference between a sequence and a series. A sequence is just a list of numbers, whereas a series is a sequence that adds all of the numbers up. Okay? So it's like if you would have you seen like at the first of the year, and maybe your parents do, but they talk about ways to save money, right? Where the first week you put like $1 in a jar, right? The second week you put $2 in a jar. The third week you put $3 in a jar, and you try to save for the 52 weeks out of the year. Okay? Seen anything like that? No? Okay. Get off Snapchat. Maybe you can look at something like that. So if I go up $1 every single year, or every single week, excuse me, 52 weeks out of the year, how much money am I going to put into this jar or savings account or whatever on the last week of the year? $52, right? Does that mean that I have figuring that I don't touch it? I don't take any money out. I don't put any more money in. But every week, whatever week in my series it is, I put that amount in a jar, a piggy bank, a bank account, something. The first week I have $1. How much money do I have the second week? $3. How much money do I have the third week? $6. What am I doing with the $1, the $2, and the $3? I'm adding everything up. Okay? That's the difference between, like, the series would be the number of weeks that I'm dealing with, and like how much money I have each week to put in that piggy bank or that jar or that bank account. Whereas the summation or the series is the total amount that I'm going to have over that time frame. Okay? So if I would put $1 in, if I would go up $1 each week, okay, that bank account or that piggy bank is going to grow, and then at week 52 or at the end of the year, I can see how much money I have left. Whenever we talk about summation or whenever we talk about a series, okay, that is going to tell you as far as where you're going to start. Okay, it's the same idea, but as far as like the first term, the second term, whenever we use summation, okay, of a series, whatever's on the back end, this is just your rule, okay, and we'll get into that later. This is your starting value. Like what number we start plugging in. So like if it's a 7, we're going to start at 7 and we're going to go to 20. Okay. The number on top is where we stop. So, like if we talk kind of like about the depositing money, if we would do, like how I would write that rule as far as if I deposited $1 of whatever week it was, okay, it would be like the summation, it would be like n equal to 1. How many weeks out of the year would there be? 52. Oh. Here, let me get it to where you can see it. Sorry. So it'd be like n equal to 1, and then we would go to week 52. And all we would have is just n. Okay? Because whatever week it is, that would be my rule. Whatever week it is, that's how much money I'm putting in to the bank. Now, what if your friend saw, like, hey, like 2 months in, say 8 weeks, 8 weeks in, they're like, man, that's really working. I'm going to start right now. What week are we like? But they're going to start. They're going to forget about the first 8 weeks, and they're just going to start at week 9. Okay. So instead of starting with $1 there, they're like, okay, I'm going to pick it up from here, and I'll just figure it out the rest of the way. So your friend says, all right, I'm going to do this. I'm still going to go to week 52. But I'm starting here at week 9. That just means, all that means is I'm going to go 9 plus 10 plus 11, and then all the way to 52. Does that make sense? Whereas, like whenever I did it, I started at week 1. And I'm going to 52. Does that make sense as far as where like the 9 came from? We're still ending at 52, at week 52. Your friend started at week 9 and they went ahead and started with $9 instead of $1. Okay? There's a difference than if they would have started like called whatever like the first week of March and they called that week 1. And ended at whatever week, then it wouldn't end at week, for them it wouldn't be week 52, it would be like week 46. Does that make sense? Okay. So like there's multiple ways you can kind of think about, as far as how they would do it. If they start with $1, then they're going to really end at week 46, or where you would be at week 46. Whereas if they start at $9 or whatever that week number actually is, that's the value, and then they end at 52, it's going to give you a different value. So then whenever we write the sum and the series, we'll talk about the series, the summation notation later, so you won't have to worry about that. What I do want you to do is be able to find the sum. Okay? So what that means is, like on 44, it says 3i. It's the same thing. N and I are interchangeable. Okay? Whatever letter K or X, whatever you're dealing with. Okay? All that means is I'm going to start at 1 and I'm going to go to 6 and I'm going to use this rule that they give me. So like if I'm doing 44, I'm going to have 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5 plus 3 times 6. And I'm going to add everything up. Okay? Whereas on one like number 54, okay? On one like 54, what number am I actually going to start with plugged in? 2. So on like 54, how it'll be set up, or how I'll do it, I'll have 2 over 2 minus 1 plus 3 over 3 minus 1 plus 4 over 4 minus 1 plus 5 over 5 minus 1 plus 6 over 6 minus 1. The most common mistake that gets made is students see that 6 and they say, hey, I need 6 numbers. No, that's where you're stopping at. Okay? It doesn't mean that's how many values you have to have. That's where you're stopping at. Okay? There's a difference in where you end and basically how many blanks you would have here. So I would add 2 plus 3 over 2 plus 4 over 3 plus 5 over 4 plus 6 over 5, and that would be my sum of the series. Like on 55. So any of the ones that go to infinity, okay, it's really going to a certain number. Because what is, like if I would just plug in, what's the first term? 1, right? So if I would do 1 over 1 squared minus 1 over 1. What's that value? 0, right? Your next term is then 2 over 2 squared minus 1 over 2. What's your next term? What if I do this again? You think so? Good guess. So what's that one going to? 0. Okay? So if they give you something like infinity, it's going to look pretty, like it's going to go to a certain value. Does that make sense?
So they'll all go to that certain value?
Yeah, regardless of what number I plug in, like if I plug in 6, if I go 6 divided by 36, okay, minus 1 over 6, it's 1/6 minus 1. Like it's going to be 0 every single time. Like they're going to give you a formula or a rule that's going to work out to be nice and neat. Okay? Anytime we talk about special series, and the formulas for special series. So like if you have a big number, like if it says I squared and it goes all the way up to like 25, do you want to add up 25 different numbers? Heck no. Okay? So what you're going to do is whatever your value on top is, you're just going to plug it into this formula. So like if it was I squared or N squared, whatever you want to call it, and it was like 25. You don't want to add up 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. You don't want to keep doing that. Okay? So in doing that, this is going to give you a lot nicer, neater ways of solving that value and taking 25 plus 20 or times 26 times 51, right? Because you don't want to write out, like if and I'm just going to pick 25 because it's easier that way. Okay, so like if it started out as 25 and you had I squared and then I was equal to 1, you don't want to do 1 squared plus 2 squared plus 3 squared plus 4 squared and so on and so forth until you get to 25 squared. Whatever you do, don't do that. Okay? Take your number, take your 25 that we have right here and do 25 times 26 times 51. Well, how did I get 25, 26, and 51? 25, 25 plus 1, 2 times 25 plus 1, and then divide everything by 6. It's going to be a lot easier and a lot quicker than you trying to add up every single number in the series. Okay, so then if I have, I'm going to borrow that because I don't remember what it is. 5,525. You probably do not want to add up 25 values of squaring whenever it's just as easy to plug it into a formula. Okay? Again, just like I said earlier, anything here, or any of these three, if it's a really big number, it's going to fit a certain category. So like the $52 that we dealt with, like instead of adding 1, 2, 3, 4, 5, so on and so forth, we could take that $52 and figure out real quick that I have 52 times 53 and then divide it by 2. Over a month span, if I have 52 weeks and I add $1 every time, I'm going to have about $1,378 at the end of the year in that piggy bank or in that jar, bank account, whatever.